Hello, I am Ayel Pincus. I'm the creator of the Practice Drawing website, and today I want to talk about the 3D models for the interlocking forms that you can find on the website, and I want to show how you can use them to practice drawing. The interlocking forms are useful because you can then use that to construct more complex forms. And for example, George Bridgman in his anatomy used interlocking forms a lot, and it's just useful to be able to do that also. I will touch on the example Bridgman anatomy for shapes forms later, but first let's start. So you see the website here, and I have a new section here, new start here, so I'll go through that. And here's it's a part of the 3D form manipulation. It's here down. It's basically adding these forms here, but nowadays you can also subtract them and take a union. I'll show that too. This getting started section is about showing how you can do certain exercises with the 3D models on the website. So this is the 3D model section I was looking for. It's these intersecting forms. I have a short guide here on how to do that also. That takes you through creating intersecting forms step by step. Of course, right now I'm going to explain this in this video, but there's also a section, a web page that explains it, sort of a primer. So I'll go into the 3D model forms. This is a model where it's just, here you see a sphere and a cylinder. In this 3D viewer you can rotate it, etc. I can go through what's possible. You can, with these 3D models nowadays, now they are both added. You see the circle and the cylinder added to each other, but you can also subtract, for example, the cylinder from the sphere. Here you can see it. And you can also do the other way around. You can subtract the sphere from the cylinder, and that allows you to create all sorts of interesting forms. This is typically very useful when doing industrial design. They can sort of make lots of you can make cars by taking two boxes and then removing cylinders at the bottom for the wheels as a first approximation. There's also an intersect. That's the space that's inside both the forms, both the sphere and the cylinder in this case. I will go back to adding, and I will go to, we can choose other models here. I will go to the combined forms in the index, and we'll start with the simplest case, which is the two boxes intersecting. I will start with an even simpler case than this one. What I'll do is make sure this is a controls panel where you can control all sorts of parameters. These are parametric 3D models, which means you can change all of the things. So I'll make the rotation 0 so that they are exactly aligned. I will position it a bit more interestingly. I'll make the blue box higher, and I will push it down a bit so that it actually cuts into the red box. I'll make the box a bit bigger. No, I want it in that direction. Yeah, that's what I want. Maybe I can make the red box a bit smaller to make it more interesting. Let's see what this does. Oh. I think this might be an interesting. This might be an interesting step to start with. So here you have the two boxes intersecting, and they are aligned. That again, here you can subtract the one from the other. You can subtract the other way around. intersection, but we will just go to the added shapes here, because we'll start with that. And what you'll notice is that the lines where the blue and the red box intersect, where they meet, those lines are parallel to the rib lines of the boxes, of both boxes, because all the rib lines of the boxes are parallel to each other. They go to the same vanishing points, and so the faces are also parallel to each other. And each time these faces cross each other, you will see that they are straight lines that also go to the same vanishing points. You can see it really well. You can see the side lines go to the vanishing point in the depth, and you see the line where both the boxes intersect there. That happens too. Now we go to a slightly more complex version where we rotate the blue box around one angle. Let's see what's... Yeah, so we've rotated here, and what you see is that here again still the line at the top is where the two faces of the two boxes meet. They're still parallel in both directions, both here and both here. You can see that the lines are still going to the same vanishing point as the... But what you can see here on the right side in the blue box is that the line for the red box, the line still goes. The line where the two forms meet still goes to the same vanishing point, way below us. But on the blue box, you can see that it's going diagonal. It's not going straight anymore. It's not the line where the two boxes meet there. I'll zoom in for clarity. This line here, or we're zooming in on, that line is still parallel in the red box, but it's sort of not. It's going in an angle on the blue box. And that gets even worse if you start also rotating along the other axis. Then suddenly the lines sort of don't converge at all. I'll move the box around a bit for more clarity. That's a bit far, maybe. Maybe we can move it up a bit. Maybe if I rotate it the other way around, and it becomes clearer. Let's see what's most instructional. Like this. So then now it's rotated. The blue box is rotated along all three axes. And you see now in the general case the lines are diagonal. Now here in the blue box, we didn't rotate along Z. So now it's probably completely, all the lines are, but what they all share in common is these lines where you see the two forms intersect. Yeah, where you see the two forms intersect, that's a line. That is a line that is both in that face of the one box and also in the face of the other box. And that's something that stays. We will go to other forms later, but that stays the same. If the line that intersects here is a line that is both on the outside of the one form and on the outside of the other form. It's useful to practice these things from a 3D model, which you're seeing here, so that you start to get a feel for what it's supposed to look like. If you practice these from 3D models often, then you can eventually start to do it from imagination, and you will not get it exactly right, but you will get the direct. You see you see the lines go in certain directions here, you will get the directions approximately right, and it will look reasonable, and it would look good basically. So that's for the boxes. Again, here we can do tricks like, it's not very useful here, but you can subtract the one from the other. It's useful to it can be useful to subtract one from the other, just to see what the lines look like, because if you add them, it can be overwhelming, all the information you see, and the one box is in front of the other, so you can't quite see what's going on. So by subtracting, you can sort of start to see what is actually happening. So it can be useful even if you're making interlocking forms where the one is added to the other. It can still be useful to look at them subtracted, so you can get a clear idea of how the angles of the lines go. And again, if we turn the rotation to 0 again, you see that the lines are straight, they're all parallel. But if we move it back, I think all three of them had a degree of 20 degrees. So then you're back at what it was. And I will now take you to the other models. So there are a cylinder and a box. This may also be a very useful thing to practice, and I'll show you why. I'll move it out a bit. I will first show, I'll rotate 0, and we'll go from there. Basically, this is an interesting form, also because of its simplicity still. A box has straight faces. The cylinder is already rounded, so that has, later we'll go into combinations where both forms are not boxes. So then the lines become more complex. But here, what you see here is that the line in one direction is parallel to both the box and the cylinder, and where the cylinder becomes round, you get a sort of a circle in the face of the box. That's typical. And again, we can subtract to get a clearer view of that. You can see that the cylinder, where it cuts the box out, there you have straight lines, and where the cylinder becomes round, in that face you have a round line, and that's when they're exactly parallel. But in the case where the cylinder is rotated a bit, let's see if I can make that interesting. It becomes slightly more. See, so basically this is a case where the cylinder basically sticks out of the box a bit. I'll push it up a bit. So 1 moment. Move it up. See, because, and this is an interesting one, I'll show you why. Because here the cylinder sticks out, but what you can do now is subtract the box from it, and I'll show you why that's interesting. Because what you can now see is that as you see, the line that intersects between the box and the cylinder is an ellipse, basically. As you can see here, basically you see them both, and here they are joined together, but the shape of the line, that is an ellipse. That ellipse is both on the flat face of that box and on the cylinder, and that has to necessarily have a cylindrical form, and that's here I subtracted the one for the other. Sorry, I meant to do this one. You can see here the cylinder is taken. The cylinder, it's a cylinder shape. If you intersect those two forms, then the line between these two becomes the shape becomes a cylinder, and that is important because even if we move the the cylinder around, say if let's move it here, basically what you have here is of course a slightly more complex situation because it crosses an edge of the box. So part of the cylinder intersects with one face of the box and the other intersects with the other face of the box. And that essentially means that there are two ellipses on both the box and the cylinder. I'll do the subtraction trick again. Basically what you see here is it's basically two cylinders. I'll move it into view. Looks like a shark. Or a fish, or a shark. But we basically see the effect of two cylinders because each cylinder is for a different face of the cube. See, there's the side one and the bottom one, and those are basically, so it cuts at as two cylinders. And again, this is a useful model to practice from the 3D to practice from the 3D model to get a feel for how these things, how the box and the cylinder intersect. And now I will go to slightly more complex forms, and there it just becomes the sphere box is still a simple one in essence, of course, because here all the faces are parts of a circle actually. So again, if I remove the other way around, sorry. Actually, all the lines that are basically, if you add them, you have the box and the sphere. And if you remove the sphere, what you see is that the lines that intersect between these two forms are all circles of parts of circles on the box. And that doesn't change because the sphere is of course spherically symmetric, so it doesn't matter how you rotate the sphere. So you can also even start moving it here. So here, let's see. Now let's push it down a bit. So the sphere here, the sphere is removed from the box, and it's a circle. It's at any position you put it, as soon as it's here, you have two circles again. So one circle on the one face of the box, and a part of a circle, sorry, and a part of a circle on the other side of the box. So this can also be a relatively easy model to practice on still. And if you add them, you get the sphere back, of course. And again, it's useful to use subtract to see what the lines do actually, to see how the lines intersect, how the forms intersect, I mean. And let's go to a more complex one. Okay, so here it does get more complex. So you have two interlocking cylinders. You can still do very cool things with them. The one can poke a hole in the other. Let's make the rotations. I don't know what that one has to be, but and this one, can it be 0? Let's check. Yeah. Oh no, sorry. This is the angle. On 90 degrees probably. Yeah. So the radius, let's make the radius of the blue one smaller. I'll move it down a bit. Maybe in the middle. Maybe a bit bigger. So here you see that there's, okay, I'll make it slightly bigger still. That's offset. But that's one of the fun things about these 3D models. You can play around with them and start to sort of experiment with them and see what happens if you change things a little bit. Here you can see that it's sort of sort of wavy shape that you get if two cylinders intersect. This could be looking like a cross of two pipes, for example. Then you also have these shapes. And now it's not very useful, I think, but you can sort of have one cylinder poke a hole in the other. I can make the radius slightly smaller now, and I think it looks cool. You can also subtract the other way. Yeah, and then you get a circle out of a cylinder out of another. And it's again, well, like I said, this is what pipes look like if you pipes, if they connect, and typically have this shape. I also have lighting. I don't know if that adds anything. Yeah, it's I don't know. It just looks cool. But this can be what a pipe looks like. It gives you a chance to sort of experiment with the 3D models, change the parameters, and see how that changes how it looks. So you start to get a feel for what it's supposed to look like, so that later on, after you have developed an instinct, you can start to do that from imagination. And let's see, is there another model? Yes, there are two balls. That's again a very simple one, actually. I thought it was useful, but again, I'll show you by subtracting. You see that basically, again, they intersect. Where they intersect is a circle, of course. This is a very simple one also. It's one of the advantages of starting with primitive forms, of course, is that they are very simple. There's a sphere, a cylinder. Let me see what interesting things I can do, but they typically get wavy forms again. Let's subtract one from the other so we can see. And you get more wavy forms. You can sort of see a Pac-Man here. You can do cool things with it. Yeah. Yeah, very big mouth. Or a moon, whatever. No, a big mouth. Yeah, so it's also a way to sort of try creating shapes. This is a very useful way to sort of create. Here you take a bite out of it. It's very seductive to play around with it. It's just. And I think we have, yeah. Cone and cube is just very complex. That's a very. I added it for completeness, and you can probably do interesting things with it. Let's play around and see what we can do. So this will be very generic. Let's see what we can, if we can move this into an interesting, useful position. So here we have because this is a slightly more complex model, but here we have, let's see what that does if we remove, if we just look at the subtract. Yeah, this is a relatively simple one, but as soon as you start rotating, you get very complicated things, of course. Those are slightly more complex shapes, forms. So then you get very more, as you can see, the lines, the intersection lines become slightly, between the two forms, become slightly more complex. Even this one, you can develop an instinct for what these things look like by just practicing, by using these 3D models for reference. And yeah, there's one with the interlocking cube and pyramid. It uses an old form for rendering still, as you can see. Doesn't allow subtraction, etc. I have to change this one still. But in the meantime, all the other models are, of course, also great. And I also had other models. Basically, that were hand coded. This is that where forms are subtracted from other forms. So this is a straight stair, and with if you click on the dice icon, it randomizes it, of course. But with these, you can also still change all sorts of things, stairs if you want. Basically, with the stair, the trick is to start with the box and then have lines in between that go to the same vanishing points, and then you can sort of construct the stairs very easily. You can remove the construction lines if you want to do it without, use the construction lines, etc. There's a puzzle mode, and then you have to, the trick is to start with this shape and to figure out where the lines go, and then you turn off puzzle mode again, and you can see what it's supposed to look like. That's all models have a puzzle mode. This is a chamfer. It's basically a straight form shape, a straight plane cut out of it. You can do this too with the 2 boxes model. You can create it yourself. But this is specifically a specific model for this. It was created before I implemented subtraction. You can subtract boxes. Again, there's a randomize button, but you can also start to do things yourself by changing these parameters. That's the nice thing about these models, is that they're parameterized, which means you can change these dimensions, and I should call them variable models, basically. And I just discovered that there's such a thing as a variable font, and where you can basically do the same thing. These are parameterized in such a way that you can set continuous values, and the model still stays the same constructionally. So many of these parameters are percentages of another value, which means that means it can be randomized. The coder can just generate a random number in the right range, and you have a new 3D model. So there's another one where it's a relatively simple one where you can cut one thing out of another. Here's the same thing as a cylinder pulled out of another cylinder. I'm not sure you can do that with the cylinder models, because I'm not sure you can rotate them in parallel, but maybe I can change that. And here you can change the inner radius and the size, etc. and how wide it is. So it's variable dimensioned models. A single rounded box, that's basically the outside's cut off. This can be useful for industrial design, where you often create objects that have nice round edges. Roundness makes things look friendly. That's why you also always see lots of, I try to give everything on the website round edges, because roundness radiates friendliness. Here's double rounded boxes. Again, all parameterized, of course. The radius of the caps, you can change that, etc. Yeah, so you can play around with that, and you can again randomize it. And yeah, this is sliced sphere, and I'll also add a half sphere soon again. I used to have one. It has to be an option that you can just see in a half sphere. But this basically you can see the perspective effect on these slices. It can be fun to create slices of a human form, for example. This can be nice. And lastly, this is an extruded form. Basically, I take a box and then I pull forms out of it. So you see here, there's a box subtracted from it, and here there's an ellipse-like thing subtracted from it, and then it's extruded into the third dimension. That's what the extrusion thing basically means. It's a relatively easy way to learn 3D. Is to start with a two-dimensional shape, and then to pull the lines into the third dimension, into the direction of the third vanishing point. This one, it said it can add forms, it can subtract forms. Here it added a triangular thing, removes a box, removes ellipse, removes a box, removes the box, and the operations that are performed are random, so you get lots of interesting forms subtracted, basically. Reduce the height. So those are dedicated models created for practicing forms added or subtracted from each other. I also have, and that might be of interest, it was actually in the same section. I'll go, sorry, that's the wrong section, sorry. In the new here, getting started, in that same section was also an exercise. This is an online tool I have, this one, where you can sort of create your own lines. You can draw in perspective. Okay, that's not very useful. The color should change with dark mode. Dark mode is relatively new. I'll make the line a bit wider. Yeah. I'll remove the line. Let's start again. I'll make the horizon higher. Oh, that's not very useful. Okay, this is not very good demo because this view is not optimized for dark mode yet. I'll fix that. It's very much in development, this website, so bear with me. I'm constantly adding cool new things. If you want to stay informed, you can join the newsletter or the Discord, where I announce new things, so you can stay informed. Now here I cross these lines, and then you can sort of remove. It calculates where the lines intersect. And now I can add lines again. It locks onto these ones, so I can pull lines from them. And I think the constraint here is this one. So I'll pull a line here. I'll put a line there. And I'll add and subtract. I'll try to. I haven't practiced this before. Let's see how far this goes. Now I can add lines. Let's say I want to subtract here. Go from here to there. Go there. Go there. And now I can remove these lines. I can remove this one. This one. And remove these ones. Because what I can do now is that's what this tool makes it easier to just draw lines that are aligned to perspective grid, and that just makes things a lot easier. I can just and here I have a box subtracted from another box. I'll remove the extraneous lines again. So it's a hassle, this. Okay. So here's a box subtracted, and I can also add a box. Let's add a box on the right side. There's space for it. So here I can sort of, yeah, or maybe in the back, then you can really see it. So I'll start with a line here. Let's pull it to the top. And let's see, like this, like this, like this, yeah. So I'll start removing these extraneous lines again. This one, this one, this one, this one, this one. for clarity also remove these lines. So I don't know which. Yeah. So what you now see is I drew a box where I subtracted a box at the front and added a box at the back. And it can be very instructional to use this grid perspective tool for that, to get a feel for what it's supposed to look like. And start to feel what that means, to try to do that. So that's the grid perspective demo. And lastly, I want to give you a slight demo of why it's useful to do this. As I have one example. Well, actually, I had it in here. One moment. There's the demo of the Bridgman arm. There's a demonstration of it, but let's go to the 3D model. Yeah, here. Because this is, I always thought this was a very cool thing in the Bridgman anatomy books. So I made a 3D model of it. Basically, this is an upper arm. And as you can see, there are interlocking forms that form the arm, and I thought it would be useful to sort of have a 3D model for reference, so you can see what it's supposed to look like. Here I can demonstrate another cool thing about the 3D models, is that I have a demo mode. And the demo mode allows you to step through it. So you see the buttons there at the top right, and you can sort of, I'll start it. So now it shows the first step. So it's you draw that one form, and it already indicates where the next form will be. And you can click on the next step for the demo, and then it shows what form to add and where the next form will be. And this allows you to do this, to draw this in any orientation. I found it instructional to copy the drawing from reference from the anatomy book, from the George Bridgman anatomy book. But I then initially I found it hard to draw it rotated. And so I figured, well, if you want to draw that rotated, maybe a 3D model is useful to practice on, so you get the feel for why it works. And so eventually you can do it from any angle from imagination. And this shows it step by step. And also I skipped that, but basically there is a drawing demo that explains it step by step, where you can sort of see where you're led through the steps. And so that's what it's useful for. You can sort of start to create anatomy, for example, by using interlocking forms. For example, the lower arm can be seen as a sort of elongated sphere and a box. That's what master artists used to do in the past. They wouldn't draw it as a box and as an elongated cylinder, but they would use those shapes, those forms, I mean, for shading. So if you really look at them, I might be able to find an example. If you look at them, you see that they shaded the arm so that the part that is a elongated cylinder, a sphere, I mean, elongated sphere, they shaded it like it was an elongated sphere. And the lower part of the lower arm, which has sort of a shape like a box, they shaded it like as if it was a box. That's very different. The way the grades change is very different, because for a box, the lightest part and the darkest part are sometimes very next to each other at the border of the box. And I'll try to find examples of that. So this concludes this introduction to parametric to the interlocking forms, basically, which you can find on the Practice Drawing This website. In the section Combined Forms, there's a whole section of these added forms. And again, you can play around with the models, change the parameters, and also subtract one from the other, so you can start to see what the lines look like where they intersect. So that might be helpful when drawing, because it's like with the George Bridgman arm. the demo mode, it removes the complexity of the other elements that are just in the way while you're drawing. When you're focusing on one thing, it's useful to have the other things removed. You can literally do the same here with by subtracting one form from the other. Addition is mostly useful for if you're drawing the human form approximated with primitive forms, but subtracted can be useful for if you're doing industrial design. I'll give a quick example. Let's see if I can. So, well, no. Well, might as well use this one. If you move it like, okay, I'll make it a bit bigger and the box a bit narrower, and I'll position it a bit different. Let me see one moment. I'm trying to. One moment. Okay, this will do, I guess. Let's subtract. Basically, okay, I'll move it down a bit. No. So you can start to imagine here that this is how you could create. Start by creating if you're designing a car. You can start by subtracting a cylinder here. Maybe you can later can add other cylinders. You can use these Boolean operations, they're called, by adding and subtracting primitive forms, or creating a new form, adding and subtracting, and then adding or subtracting that from yet another form. And it's a very useful way to come up with beautiful industrial designs, human-made designs. So that's designs between nature and what human designs is often very different. If you look at the Tadao Ando architecture, you often see straight lines and circles and cylinders and so. And if you see that in a landscape, you see that all the trees and all the other things are very organic and flowy. And that's a very interesting contrast. So it would stand to reason that you construct these things differently also. So if you a man-made thing like a car or a table or etc., those are all boxes and cylinders, etc. And if you look at nature, it's much more organic. Things are added together, and then it becomes more about adding forms. An example of that would be, that's out of the scope of this thing, but it's kind of the same. We have these blob shapes. Let's see. Oh, it's the wrong place. Oh yeah, the organic forms. You have these blobs are basically the same idea. You have these blob-like things. It's another model, and this is kind of also these are also intersecting forms. These are blobs that intersect, that combine basically into a more complex organic form. This is more what things look like in nature, of course. This this looks much more like how muscles can bulge, etc. So that concludes the introduction to the intersecting forms and how you can use them for drawing practice. You can also reach them through the 3D models at the top of the page. There's a link there. This is a page that introduces it's a landing page, introduces the 3D models. You just click through there and then go to the interlocking forms and practice drawing these in your sketchbook. It's fun to do. You can have this on your phone. If you have a sketchbook and pen with you and your mobile phone, you can literally, anywhere you're waiting and sitting, you can start drawing. Okay, so that concludes this YouTube video. I hope you found it interesting. If you want to stay informed of improvements I make to the website, I'm constantly adding new models. I'm constantly improving things. Recently, I added the possibility to subtract these forms from each other. Initially, you could only add them to each other. Those kinds of improvements, I announced them in my newsletter and in my Discord. So if you want to stay informed about changes, additions and improvements to the tools I have on the website that can help you practice drawing, then join the newsletter and the Discord. Okay, thank you very much for listening. Bye-bye.